The standard deviation rule, also known as the empirical rule, tells us of a very nice property of normally distributed data. So whenever we have distributions with a normal shape, we know that 68% of the data values will fall within one standard deviation of the mean. Okay. And we know that 95% of the data values will fall within two standard deviations of the mean. And 99.7% of the data values will fall within three standard deviations of the mean. So let's do a quick example. Let's suppose that on the first statistics test, the test scores were normally distributed. So they had that bell shape, and the mean was 76% and the standard deviation was 7%. So what does that tell me about the test scores? So I'm just going to draw like a little diagram. And so the mean was 76%. So I know that one standard deviation above the mean, 83%. And one standard deviation below the mean would be 69%. So I immediately know that 68% of the data values fall in this range. And that's from the empirical rule. Okay. And then I know that going out one more standard deviation to 90% and 62%, we know that 95% of our data values are going to fall within here. So 95% of the students scored between 62 and 90%. And then going out a little further, if I were to go out another standard deviation, I know that would be 97%. That's three standard deviations here. And going down to 55%. Okay, that's three standard deviations below the mean. Okay, so we know that 99.7% of the data values are falling. So virtually all the students had to have fallen between 55% and 97%. And that's what the empirical rule is telling us. We can use the empirical rule to answer questions about normal distributions, just basic questions. So let's take a look over at some questions. So the first question says, use these standard deviation rules. We can see that 95% of the test scores lie within what range? Well, using the standard deviation rule, we know that 95% corresponds to two standard deviations. So I can immediately take a look at my distribution here and see that, okay, that means test scores from 62% to 90%. Okay, so that's just two standard deviations. The second question says 50% of test scores lie above which score? So this is just asking you for the median, okay? And for a normal distribution, the median, the mean, the median, the mode, they're all the same. So that is just my mean, okay, which is 76%. What percent of data values lie between the score of 69 and 83? So if I go back to my normal distribution, I see 69 and I see 83 here, and I immediately recognize, oh, those are the scores that correspond to one standard deviation below the mean and one standard deviation above the mean. And I know that 68% of the data values fall within one standard deviation. This is just one standard deviation, okay, around the mean. Finally, what percent of data values lie above a score of 55? So again, going back to my distribution, I can see 55 is down here. So that is three standard deviations below the mean, okay? So I happen to know that 99.7% of the data values lie between 55% and 97%, right? So that this area This takes care of 99.7% of the data values. So I at least know 99.7% of the data values lie above 55, but we also have to consider these tails here. So what percent of the data values lie in these tails? Well, if 99.7% lie between 55% and 97%, then it must be true that in these tails, between these two tails, we have a leftover of 0.3%. And we can say that half of this amount, so 0.15% of the data, of the test scores, lie above 97%. And the other half, 0.15% lie below 55%. Okay, so if your question is what percent of the data values lie above 55%, then I know that that's going to be 99.7% plus 0.15% to account for this little tail here. Okay, so I'm just going to write that down. Okay, and this just represents the test scores that are above 97, and this represents the test scores that are between 55% and 97%, and that gives me 99.85% of the test scores. Okay, and those are our answers.